Hello guys, good evening. Welcome everybody to my channel on YouTube. Today we will go through the most important drawing used by engineers and technicians. Nobody can be able to work in the maintenance field or installation field if he can't able to read this type of drawings. So today we will start explain how to read this type of drawings. The drawings is called schematic drawings, or sometimes it's called schematic diagrams. So we will go through schematic diagrams. First, we need to know why it's called schematic diagrams. Schematic diagrams it show us everything. The picture is in simple way, very simple. Show me motor, controller, coil of contactor, switches, push button, everything for using for this circuit. Schematic diagrams is a picture representative all this component, okay, in a symbol as per IEC or NEMA. Schematic diagrams it show us the process and the sequence for operation, how it's the equipment, our equipment it's operate. Like if you can see this motor, we can see this motor for power line. We have a power line circuit here and power circuit, and we have a control circuit. We can see for power circuit we have a circuit breaker and thermal overload and contactor and the motor. So it show us the process or how is the power flow coming from power to our equipment. That's called power circuit. Other way, here we can see here the control circuit, how we can control this motor, how the motor can start or stop, okay, and what is the element can affect in the energize of coil of this contactor. So schematic diagrams sometimes is called wiring diagrams or circuit diagrams. Schematic, why we needed schematic diagrams, why we needed to using it, what is it? It is very important. We said it is very important to us, so why we need it. Okay, the aim for all using schematic diagrams, first to understand the sequence of operation and how the circuit is operate, okay, so and also the function of each element in the circuit, whatever in the power circuit or the control circuit. Now we nobody can tracing a fault or fault finding for troubleshooting whatever we without read carefully this drawing and understanding the schematic diagrams, okay. So it is help us for fault finding and tracing the fault and troubleshooting, okay. Let us take as example, if we can't see this lamp and we have a power line, two line, okay, for this circuit. So when the lamp it will be lighting, how, when, okay, we can see here this lamp, okay, this switch is closed, normally closed, so the power will flow, the current will flow through this circuit from here and we will read and here until arrive to lamp and return back. So that's a two line for here. So we need all this be closed to let the lamp is indicated here, okay. So this is already closed, so no problem. So the current can be here to here, it is okay, no problem, but here it is open. We needed this first switch S1 is closed, switch push button 1 here must be closed, and also circuit breaker must be closed. If circuit breaker closed and switch closed and also S2 is stop, we can set this normal close, maybe it is emergency stop or stop push button is closed, so the current will flow to indicate that lamp. The lamp now will be eliminated, okay. Okay, so this help us how to understanding the sequence for operation for our equipment and how to trace the fault and help us for fault finding. Here we can find here some symbols for used for schematic diagrams for NEMA as per NEMA and as per IEC, okay. We can see here like a capacitor. We can see here also magnetic circuit breaker. Here the symbol for circuit breaker as per IEC, here as per NEMA. Here coil of contactor or coil of relay. We have also the contact normally open and normally closed. We needed to talk about this first. We must understand in schematic diagrams, all the circuit here, if can, oh, all the circuit here must be drawn during non-energized. So the switch during normal operation, non-energized, without any push button here, it is already normal open. Okay, and this is also, this contact is normal open, this switch is stop, so it is already normally closed. Okay, so we draw all our symbol in non-energized situation. Okay, and this is coil contactor, this contact is normally closed, that's overload. And for during draw we can find the power will be above here, and the neutral, that's a phase or line, and neutral will be here down. On left side will be power or line, and neutral will be right side. If we using a control circuit DC, so we can find here a positive and here a negative, or we can find in here in this way, in left side will be a positive and negative in this way. Okay, a schematic diagram for line non-reversing starter with start to stop push buttons for electrical motor, and that's a very simple control circuit for start stop motor. This we have here in by standard NEMA, and here with IEC. We have here power circuit that's drawn by NEMA standard and by IEC standard, and this is control circuit by NEMA standard and IEC standard. Okay, we can see here this is a motor 3-phase supplied by 3-phase power through a contactor, that's a contact of contactors. Okay, and this thermal overload relay, this symbol for thermal overload relay by NEMA, as we can see here by IEC, and the circuit and the contact of contactors and contact of contactors for 3-phase motor here by IEC. So that's a power circuit, very simple. Power supply coming for in the panel through a contactor through overload relay, after that a connected to motor, that's a power circuit. For control circuit we can see here it is drawn here by two line 1 and line 2, and that's a control circuit, power supply for control circuit. The coil of contactor, the symbol of coil of contactor M. If we needed the motor to run, start the motor and running, we need energize the coil of contactor. So if we needed to energize this coil of contactor, the current must be flow from L1 to L2. Will flow through thermal load overlay relay, that's a contact of auxiliary contact of overload relay. Okay, that's normal close. If normal close, this means thermal overload relay it is working okay, not have any problem or failure for overload. Okay, and we have a stop push button, normal close. We have a start push button, is normally open. When press in start push button here, so will be closed, and the current will flow through stop push button and start push button and through overload relay, and after that will energize the coil of contactor. Once energize the coil of contactor, so all the contact here will be closed, and the power will flow through contactor and supply 3-phase motor, and the motor will running. Okay, we have here see that's a parallel contact for auxiliary contact for contactor M. Okay, once it is closed, energized, so this contact will be closed. Once it is closed, we'll make a bypass for start push button. Why we needed this one? Because if this switch push button will back to normal operation once I remove my thumb on this push button, so will back again to open. Okay, so the circuit will open, so needed to make parallel auxiliary contact for contactor to be parallel with start push button, to make other pass for a current, to make sure the current will flow the circuit even I remove my thumb from start push button. This circuit is very simple for start stop motor and very easy to understand. Now for troubleshooting, if coil of the motor is not running and the power is okay, the contactor is okay, and thermal overload is okay, maybe it's a control circuit, maybe the power for control circuit not have a power, so we needed to check the power for control circuit. Maybe the start stop push button stop is have a problem, and it is not connected and not closed, so we needed to check so stop push button. Maybe overload relay is open, so we needed to check the point or the terminals for overload relay. Okay, so that's aim for schematic diagram to make us understanding the process and the sequence for operation to operate this motor, and can tracing the troubleshooting. This the diagrams very easy to understand. And let us go for another one that's using for forward and reverse the motor. So motor here will using two contactor, one contactor for using forward direction and the other contactor will using for reverse direction. Okay, to understand this, we have a power here and we have a two contactor. Between the two contactor we have this symbol that mean mechanical interlock between two contactor. That mean when the contactor is closed, the reverse contactor will never be closed at the same time, to don't make a short circuit. And if reverse contactor is closed, that mean a forward contactor will be open. After that, connected to thermal overload relay to the motor. Okay, that's a power circuit for forward reverse motor. Let us go to control circuit. If you look in control circuit, we have here two coil of contactor, forward and reverse. Okay, and that's a mechanical interlock between two contactor. Here the current will flow from line 2 to line from line 1 to line 2 through stop push button and start push button, and this auxiliary contact for reverse contactor. This electrical is called electrical or named electrical interlock. That means the contactor, forward contactor, will never be closed if the reverse contactor is energized. Again, the forward contactor, the forward coil of contactor will never energized if the reverse coil of contactor is energized. That's called electric interlock. We can see here the auxiliary contact for forward and reverse is normally closed. So if energized, the coil of contactor reverse direction is energized, so this contact will be open. This means the coil of contactor for forward will never be energized. Okay. And this normal is parallel operation. We have a two parallel operation here. That here we have a stop and the start and the reverse auxiliary contact for reverse to energize if this closed and this closed, and we press start for forward, so the coil of contactor forward will energize and the motor will be run. And otherwise, when it's stopped and needed to rotate the motor in reverse direction, so I press start for reverse. After that, the current will pass through this line till energized the coil of contactor of reverse. Okay, that's very easy to understanding the schematic diagram, and hopefully we understand the sequence and how to tracing the fault and how to draw the schematic diagram with two drawings, start stop, okay, and forward and reverse. Finally, I would like to thank everybody for watching this video and hope you understanding the schematic diagram. If you like this video, please subscribe our channel and share this video. And if you need and you would like to get a PDF, please write your email in the comment and we'll send it to you by email. Have a nice day and good luck.